Are there any scale staff here? Am I supposed to wait for any kind of signal, or should I just start on time? All right. Excellent. Just brief disclaimer, despite the logoed shirt and the logoed slides, I'm not going to be talking about our products to any great degree or anything today at all. So rest assured, I'll be staying above that level, but I do want to start out by just thanking Sophos because they did pay for my airplane ticket, my hotel, my food, and my beer. And on that note, I have to be very gracious and thankful to the company for supporting me in this. But aside from that, that's about the extent of the Sophos part of this presentation. Just briefly, for those of you, I recognize quite a few faces out there. I do quite a few events here in Southern California, and I was asked by Maddie, who I met at B-Sides LA and ISSA Orange County and a whole bunch of other security events around Los Angeles in the past, to come out and speak at scale this year. And I said, that'd be great, but I actually have to find the time to do research on something that would matter to open source and Linux enthusiasts, which I am myself. So I've been using Linux full-time on my laptop, my desktop, for all of my professional work, exclusively for 3 or 4 years, as much as possible, which is to say that to file for my vacation, I have to boot Windows, and that's pretty important to me. So I boot Windows, and I file my vacation pay, and those kinds of things. But pretty much exclusive. I do all of my work, all of my research, all of my presentations, all of my work in a Linux environment, and it's something that commercially we don't have a reason to talk about a lot at Sophos, and that our clients are mostly concerned with their Windows computers. And so I thought it was a great opportunity when suggested that I come down here at the end of last year for this. I said, that gives me like 2 months that in between things I can try to do some research that kind of talks a bit, the role Linux plays in all of this. And I really should have, when I pitched the talk, I should have put question marks at the end of the title because I wasn't sure what the results were going to be. I had ideas in my head from working day in, day out in the labs and looking at malware infections and looking at compromised websites and looking at all these things that I see every day in my job. I kind of had this idea of the role that Linux played in it, but I wasn't really sure because I hadn't ever done proper research. Like I hadn't gone and scientifically extracted data that we had in the lab and said, what impact and what role does all this really have? So this is really the culmination of the last 3 months of my spare time digging through our labs data and finding out what role Linux does play in the malware ecosystem. If you don't know me, I mostly get to do research and run around and talk about it, which is pretty cool. I'm American and Canadian, so I probably sound slightly funny to some of you, and that I should sound funny to all of you, whether you're Canadian or American, because I've managed to pick up enough Canadian I no longer sound American, and I certainly don't sound Canadian. So I don't really fit in either place, but I grew up in Michigan, I work in Vancouver, and my job at Sophos is working in our research labs and then finding interesting things in the data and writing about it on our blog, Naked Security, and doing podcasts and flying around to security conferences and sharing the research information with the world. So I kind of started out with, why would Linux be a target? Like, what are the primary reasons criminals might target Linux systems as opposed to targeting Windows systems? And clearly when we look at the payload, the actual malware, things like banking Trojans and DDoS bots, and the vast majority of all that stuff is Windows, right? It's Windows, it's Win32, and it always has been, and certainly things like Android have been climbing up in the ranks compared to Windows, but not any big thing. But there's tons and tons and tons of infected Linux systems out there, and the question is, if your talent is in writing malicious code for Windows, why bother with Linux? And I basically came to 3 conclusions, one of them is obvious because it's the case for almost all malware writing if it's not espionage-based, which is money. And even espionage-based malware, you could argue, is for money, depending who's behind it. But the other 2 seemed really interesting as I started going through it, which was, 1, Linux boxes are primarily playing a server role. There may be a lot of people here at an event like Scale running Linux on their laptops and desktops, although I see a suspiciously high percentage of people carrying around Fruit Company laptops. But let's call it Unix/Linux and leave it at that and say that, but still a tiny percentage of the total computers out there, and yet Linux boxes are very common. They're just not common in our hands at home and in our laps. They're common at the server side, and of course that means they have access to data centers. They have redundant internet connections. They have a lot more resources available to them than most any desktop or iPad or any other thing that we're carrying around with us, right? So that's very appealing to a criminal from the standpoint of distribution, right? This isn't about, you compromise one Linux box and you've got the power of 1,000 Windows boxes that are sitting at home behind a Comcast cable modem. because that box is sitting in a rack at not at Rackspace, they're a customer of ours, but perhaps they're at GoDaddy, something like that. And somebody that's not a sponsor of Scale. And then the next thing, being that I live right near the 49th parallel, which is the border between the U.S. and Canada, of course, I found this great photograph of the U.S.-Canadian border going through the forest there near the Rocky Mountains. And it goes on like that for about 3,000 miles. Largest undefended border in the world, right? But that's the beauty of Linux boxes. They're undefended. Nobody's actually doing anything to protect these things from compromise to any great degree. People prop them up to run their Drupal and their WordPress and their this and their that and these VPS hosts, and nobody's running antivirus. They never even bother to configure the firewall, and if the firewall is on by default, they have to turn it off because it's not worth configuring. There's very little hardening going on, right? Things like ASLR that are so common in Windows and Mac when you're writing exploits to make it hard to write exploits pretty much don't even work in Linux. I mean, it's so hard to securely code in a Linux environment that most of us have to turn that stuff off. SE Linux, if you've ever tried to use it, I mean, I think you need a master's degree in Red Hat to start, and I think it's great. I mean, I use SE Linux, and I encourage you to use SE Linux, but how many percentage of the hundreds of thousands of Linux boxes sitting out there on these virtual hosts, et cetera, have any of those things, right? And the vast majority are going to have none. And so that undefendedness means that you have persistence for a long period of time. You infect a Windows server, it's infected for 2 weeks until the antivirus vendor detects something, because nobody in their right mind would run a Windows box without antivirus. You infect a desktop and it's similar kind of things. The next patch Tuesday it stops acting up, or some update gets deployed. So you've got limited windows of opportunity to exploit and extract cache from those victims. But a Linux box, you can compromise it, and it'll probably stay compromised till 12 years from now when somebody says, what is that box in the corner? I don't know. Turn it off and see if anything happens. And that happens a lot, right? I mean, we all have those. If any of you have, are in any kind of reasonable-sized IT environment, there is that box which everybody's afraid to touch because nobody's quite sure what's on it. And the guy that had the password quit years ago. And what if that's the thing that runs the badge in the elevator, right? Like, so it's not a new problem, of course. Hopefully, I hope that because you chose to come here, you're not a climate denier or a Linux security denier, that everything is just fine, and because it's based on the concepts of Unix, there couldn't possibly be a problem. We've had a lot of incidents, and I'm hoping that this has been a wake-up call for our community, actually. We've been pretty cavalier about security, even when we're smart about it. I mean, some of the people that know the most are still pretty lax about it because it doesn't rank as a priority compared to all the other things they have going on in their professional responsibilities. And after Heartbleed and Ghost and these things, unfortunately Ghost has turned out to be, hopefully, very, very low impact in the end. But we're starting to see how these little components that make up a Unix world, that then you use them over and over and over in all these different ways throughout the ecosystem, can cause a tremendous amount of panic and damage when they go wrong. I mean, OpenSSL, we'll never know all the places that the broken OpenSSL with the Heartbleed flaw was embedded, right? Like, I mean, I'm sure it's in somebody's smart refrigerator, and like, but I mean, we use these little things and we spread them out, and we never consider how are we going to update these things. If it works and it's reliable, and you've got something as reliable as glibc, you don't think, well, what am I? Is there ever going to be an emergency where I have to, like, mysteriously upgrade my glibc? And it hasn't really ever happened in our environment, in our world. So we don't really have good procedures and practices for figuring out where are all the versions of OpenSSL. And in fact, at Sophos, we use OpenSSL in the majority of our products. We knew precisely which versions of our Windows product have which versions of OpenSSL going back to 1980-something or 90-something when we started using OpenSSL in the product. But all of our Unix and Linux products, we had no idea. And when this happened, we literally had to have all of our dev teams run out and say, what are you running? And in some cases, it was old 098 versions, and other ones were running current, 1.01, I believe it was, release, and we had to take action. But we didn't have an inventory because it hadn't really occurred to us. We were already prepared in the Windows world again because this happens so much that we're reliant on something that suddenly goes sideways, that we've got all these processes and procedures around it to make sure that we're ready for it. And this one shocks me. I mean, one of the most successful Linux worms ever was called RESTB or RST. In 2008, I think, 2008, that was a blog that we wrote on our Make It Security blog, warning Linux sysadmins to please clean up their systems The malware had been written in 2002, so this was 6 years after it had been out, and there was a million free cleanup tools, and ClamAV would find it, and it was trivial to know if you had a problem. And 6 years later, this was the top list of machines that we were detecting still calling into command and control servers. And the total at that time we could clock was 158,000 Linux boxes that were calling home to this command and control server. I asked the labs 2 weeks ago to check, because we still have the sinkhole domain that we were using to measure it back then, and I think it's still something around 35,000. So we're 12 and a half years those machines have been infected and haven't been cleaned up. So this is a real thing. Most recently, I don't know if any of you remember hearing about this, there was something called Dark Leech. It was primarily researched by a really smart guy in Japan. Unfortunately, he only writes his blog in Japanese. It's called unixfreaks.co.jp. The Google Translate is surprisingly comprehensible for talking about vulnerabilities in code. But Dark Leech was interesting because we still don't really know how it infected Linux boxes, but it became a really big thing. So about a year ago, this is a chart of all the malicious URL detection names that our product calls a bad website when it detects it for a 2-week period when Dark Leech first came out. And the orange piece of the pie here, mal iframe al, those are indicative. That's the detection name we detect when the Dark Leech infection was infecting a web page. So you can see it was something like, I think it ended up being 58% or 59% of all of our detections for a 2-week period were just that worm. And what was cool about it from a bad standpoint, I guess, is it was an Apache module. So they would compromise the machine, and then once they were on, they would custom compile the Apache module, which made it harder to detect. It's something we don't see in the Windows world, right? People don't compile their malware on the Windows box after they infect it. But on a Linux box, the tool chain's there, right? GCC is almost always installed on all these boxes, whether it should be there or not. And that makes it easy for the criminals to avoid detection, because you don't end up with the same ELF binary on each system, because you compile it and it ends up being different binary code. And they were compiling this Apache module, and what it did was it silently injected malicious JavaScript into all your web pages in real time. So your website would be infected, and I call you on the phone, and I'm like, hey, beaniebabies.com's infected. You really need to clean up your site. And the guy would go in var ww and look at the files and go, no, they're fine. You're full of crap. You're wrong, right? Because the files weren't touched. It was doing it dynamically through an Apache module. And even more clever or annoying was that they also built in an IP whitelist blacklist mechanism into that module, so that if anything from the class C that the server was on browsed to it, it didn't inject the pages. So the admin would browse it and go, no, it's clean, right? But if you browsed it from a cable modem at home, it would be infected. And they also blacklisted, of course, all the antivirus vendor common IPs that they know we use to spider the web, so that we wouldn't see it in our normal spidering activities, which is rather clever. But I mean, this is the kind of thing we're facing, the risk that we're posing out there, right? So the harm to the website operator, ultimately, the biggest negative you could argue to the person who was infected in this case is that their reputation might be harmed, right? Your business is infecting your customers. It's kind of a bad look. But beyond that, it's not doing anything to your machine. I mean, it's stealing a tiny amount of resource, but it's not like a Windows thing which is trying to steal your banking credentials when you're infected, or this kind of thing. It's a different nature of threat than we see on the more common platforms. So my methodology, I went into the labs. I exclusively used, I shouldn't say exclusively open source tools, because there were a few lab tools that we built for our own use that I had to use to get the data. But I basically, I grabbed the epoch time for February 1st at midnight, and I grabbed the epoch time for February 6th at 23:59:59, and I stuffed that into our web URL service in the lab, and I said, give me all the malicious URLs that we cataloged from precisely that week, which is the first week of this month when I really got serious into the research for this talk. So I ended up with 178,635 malicious URLs, which is pretty average for us. We average between 25 and 35,000 malicious URLs a day that we detect. Those are new, additive to the previous catalog. So I took just those freshest 178,000, And we put them in two big buckets. Now, of course, human beings aren't involved when we have 178,000 URLs, right? Machines do this. We use different techniques, but largely depending on how we're finding them and where we're finding them, we go, okay, they're in one of two buckets. They're in the infected bucket, which means it was some innocent person's website that was modified in some way to direct traffic to something malicious somewhere else, which is the most common thing we see, right? Your WordPress blog is infected. They don't put malware on your WordPress blog. They put an iframe in a footer tag so that every single one of your pages just has an iframe that points at the bad guy's controlled server somewhere else. So those are the ones that are in the infected bucket. And then there's the repository bucket, which we call known malware destinations. And the repository bucket means that's where they're actually hosting the malicious code, the Windows Win32 binary that they're trying to deliver through the Java exploit to everybody's desktop. And so you're either storing the malware or you're directing traffic to the malware, really the two categories there. And I just used an assortment of GNU tools and cut and grep and unique and all this stuff on the data set. And this is what I ended up with. When it was all said and done, it turned out to be, after deduplication and stuff, it was about 120,000 some odd unique IP addresses that represented that 178,635. And that was the breakdown. So then I started looking at them, okay, what kinds of interesting information be out there? We want to see patterns. What makes it more likely that a Linux server might be a part of this malware ecosystem? And if so, what part of it does it play? What role does it play in that ecosystem? So looking at the breakdown here, you can kind of see, once I got down to the point percentages, I stopped making colors in the chart because you won't see them. If you have any questions throughout, like if it's a short one, feel free to throw your hand up and ask anything. If not, more existential questions we can hold for the end. But you can kind of see the breakdown, and it's not terribly surprising, right? To be fair, this is when I looked at them, I'm like, okay, this is sort of representative of what I would expect web servers in general to be on the web. There were a few surprising things to me. Amazon and Akamai, out of that 178,000 URLs, each were about 300, which was exceedingly low, I thought, because at one point we were having real struggles with people using Amazon EC2 instances for malicious purposes. And we didn't see hardly any of that currently. So Amazon, I would argue, I don't know how they're doing on spam, because they also were a big part of the spam problem for a while. But certainly on the malicious website, they seem to have done a really good job cleaning up. There was very, very small amounts of it. And of course, Akamai, I presume it would be their customers who potentially were victimized as opposed to them hosting something themselves. Although Akamai, I think, also owns some anti-DDoS services, so there's some rather questionable websites behind some of those DDoS filters. Things like the lulsec guys and the what was the one over Christmas that were DDoSing the PlayStation Network and the Lizard Squad, right? Yeah, so a lot of these guys run their services behind things like Cloudflare. So I'm not sure what the Akamai ones were. I was a bit surprised to see Lightspeed. I think Lightspeed ended up being about 3.5% of the URLs, and that was it was 3.3%. And I didn't really realize it was that common. They do have an open source version of Lightspeed available now, but I've never heard somebody say, yeah, I use Lightspeed. So I was a little shocked that it was 3.3% of the total, but that's the basic breakdown. And then I thought, well, I'm looking at them in different ways, right? So let's start by comparing those totals against the Netcraft data, right? Netcraft just published their February poll on what web servers are most commonly used on the internet. And so went kind of through that, and that was when some more interesting things started coming out of the data set a little bit. Now, I had to break Microsoft into two pieces there because Netcraft buckets them together. When I did my survey, they were actually separate. So IIS itself was about 17%, and then the other 3% is this Microsoft UP&P, and I tried to figure out precisely what that might be, and it turns out it might be everything that's not IIS. So like XP had a web server you could turn on that was like Microsoft Web Services or something with a tick mark in one of the settings. That called itself Microsoft UP&P server. Xboxes call themselves Microsoft UP&P servers under certain conditions. They will listen for web traffic. I'm not sure how they would get infected, but there were lots of them in the data set. So I don't know what all these Microsoft things were, that 3% of this number, but they call themselves UP&P, and they did have malicious redirectors behind them. But for Microsoft, at least, they were 7.5% less than the amount of web servers actively hosting content on the internet. So that kind of supported my idea that Linux is probably one of the primary distribution methods. Infected Linux servers are one of the primary distribution methods for malicious content. Now, Apache being below its Netcraft numbers surprised me, because I expected Apache to be the big number that was going to just jump out, because every amateur running a Linux website that doesn't know much loads a stock LAMP stack, right? They've got, they've got Apache, they've got, I was going to say MySQL, but I'll say MariaDB because I have friends that work there. But you know what I mean, right? Like that would be your expectation. The unpatched bad PHP code running on the Apache server that somebody propped up for $2.99 at GoDaddy. And yet it was below the average when I looked at it in aggregate. Nginx was just a touch above, but Google was way above. So I thought I want to look into that a little deeper. One, Google Web Server isn't really something any of us would run, so that suggests that it's something Google hosted, and why are the numbers so high? So I broke it down again into the buckets I'd created to see if anything more jumped out that might help me identify any of those anomalies in the numbers. And that's where I thought it started getting a lot more interesting, because now I saw, okay, now Microsoft's down to 10% below their Netcraft survey results for the infected websites, yet Apache suddenly jumps way up to plus 16%. And when I started later on, I've got some more stats in a few minutes, looking at things like CMSs or what other tools might be involved, right? Because it's not that Apache is vulnerable. I mean, there are Apache vulnerabilities, but we're not aware of any of them being massively exploited for any reason. That's not been a crisis. It's likely the application layer sitting on top of that stack that is probably leading these sites to be compromised in the end, or some other contributing factor. But Apache was the vast majority of the infected sites, and that supported my original thesis that, okay, people just setting up a server, don't know what they're doing, don't secure it, don't ever patch it, and something bad happens. And then Nginx was just a little below average, and all of a sudden Google just vanished off the chart. I mean, on the previous chart, Google, on the aggregate, it was up 7%. Suddenly, when I look at infected sites, it's pretty much barely there. So that kind of suggested what obviously the flip side of that is, which is huge numbers of Google and Nginx, percentage-wise, compared to the Netcraft averages. So, and this is supported by a few weird things, especially the Nginx number has been something we've suspected. Whenever I'm sitting in the lab and I just netcat to a URL that we want to poke at, it's almost always Nginx when it's the one I'm trying to fish the malware from. And I had never had any data to support it. I mean, this obviously still shows that Apache is more commonly used by 10% than Nginx is, but it does show that it has a disproportionately large number compared to its market share. And that was kind of interesting to me, because the majority of the malware is Eastern European, and there seems to be a preference for Nginx in Eastern Europe, I guess because it's Russian written. I don't know. I use Nginx just because it's amazingly fast and it works beautiful for me. But it was something that we saw very infrequently in compromised websites where somebody had broken in through their insecure WordPress, and we saw much more commonly as the place where somebody just dumped a file. And the other thing, when I asked the guys in the labs about it, and I don't have data on this, that was interesting from that was that the most reputable hosts in the world won't, there's kind of three categories you can be in. You can be in we're a really reputable host, and if we detect anything dodgy on our network, we take it offline without even asking you, and you have no option in it, and we're going to give you a call and yell at you because you had something bad happening. Then there's we're not really bad guys, but we really don't charge enough to give a crap, and we'll host anything until somebody complains loudly enough. And then there's bulletproof hosts, the third category, which are largely in Ukraine, Estonia, Moldova, Russia, that intentionally host the stuff, advertise that they'll host the stuff, and will keep you online forever. And those guys have a tendency to all run Nginx. And so I think that's where that number probably comes from in our experience. The Nginx guys tend to be at the bulletproof host, and they host a large percentage of the malware that's out there. Because if you set up a server tomorrow morning on Rackspace and you have a Windows, a piece of Windows malware sitting in a folder that can be publicly accessed, you will go down very, very, very fast. They do not tolerate that on their network. They do not want their IPs to get dirty reputation, and they don't want to be a part of the malware ecosystem, and they just won't tolerate it. And the known malware host guys are sort of the opposite, the bulletproof hosts. And a lot of them have been shut down over the years, but there's still plenty of them out there, which is great. I personally love the fact that there's known malware destinations and places where they encourage malware authors to host their stuff, because it means we can block one set of IP addresses and walk away and know that there's almost never anything good there. It's all child porn and malicious stuff and all this kind of thing, and we can safely block it and know no customers are going to complain. And for them to pick up a new ASN is rather hard. They're not very well liked by the rest of the hosting community. So it's not such a bad thing, really. So then I started looking at apps, and unfortunately this is where I started running into time constraints, because it's really hard to accurately identify what a site is running when you're trying to look at 178,000 things. And when you're looking at them by hand and you view source on a page, you can almost tell by looking at it immediately that, oh, this is Joomla, or this is this, or this is that. But it's kind of hard to actually automate it. So I took a stab at it the best I could, and a couple things jumped out. I mean, Drupal was almost non-existent. In the data set, there were very, very few Drupal sites, and I'm not sure why. Other than apparently they're not infected all that often, or there's two things. Either they're not infected very often, or I'm really, really bad at telling if it's a Drupal site. Because I basically was constructing regexes to look through. I downloaded all 178,000 web pages, and I was going through using fgrep and other things to try to find patterns that to me were unique to a page generated by one of these content management systems. And the infected and repos were kind of even on the WordPress side, quite a lot more on the Joomla side than for infected as opposed to repositories. And the one that really was interesting was cPanel, because I got to thinking, well, there's the main ways we know these guys get in are bad WordPress modules, poorly coded modules for Joomla and Drupal, and SQL injection on poorly coded manual built sites, and then these cPanel things on Bluehost and GoDaddy type environments, one-on-one.net, these kind of guys that mass host for people that don't know anything and they need a point-and-click GUI to manage their PHP admin panel thing, right?
Could you go back to previous slides?
Sure. I lost my...
So why Google is so...
Oh, I forgot to talk about Google. Thank you.
Yeah.
No, yeah, so I started digging through that. The crooks love Google for hosting the malware, and apparently Google's not doing anything about it. That's basically what it is. I went through it all, and it was like 96% of them were Blogger and Blogspot sites, and they're just hosting the malware. Like, it appears Google's not scanning it, or if they are, they're doing it very poorly. And I don't suspect it's because Google doesn't know how to find malware. I suspect it's because they're not trying, and maybe this will encourage them to try harder. Because if we look at things like antimalvertising.org, which is a group that Google funds for big advertising, online advertising things, their scanners find almost everything bad almost always. Try to find a malicious Google AdWord. I mean, Google's really, really good at finding bad stuff. They bought VirusTotal, right? Like, they have tons of intelligence inside of Google to identify malware, and they're really good at it when they put their mind to it. And of course, looking at the percentage of their revenue that's advertising, not surprising that they put a lot of effort into making sure the ads are clean, because it could wipe them off the map if they weren't. The question is why they're ignoring Blogger and Blogspot. I don't really know. I mean, if there's anybody from Google that feels empowered to comment, I suspect it's not my department would be the answer if somebody sitting next to you is from Google. But and it's a big company, and I'm not trying to pin a lot of blame on them, but I would like to draw attention to it. I was surprised by it, and I went through them, and almost every one of them was just flat out hosting a piece of malware, or some malicious code that was directing to malware as well. So it's not all of the ones that are categorized as repository. Like I said, humans didn't go through these, so the machine is wrong about certain things. And I'll kind of talk in a second about how we throw them into the buckets, because it is an automated process, right? But yeah, they weren't Google.com addresses, be assured of that. And they certainly weren't related to AdWords or Gmail or other well-known branded Google items. They were mostly Blogspot. Yeah, so the cPanel numbers obviously make it pretty obvious that perhaps that's one of the primary ways in. Yeah?
So I'm not a big advocate of cPanel, but I'm just wondering in some of these cases if it's possible maybe that if it's name-based virtual hosting, the other sites in the box are either hosted using a different host header or
Yeah, this isn't definitive for sure. So I should repeat the question. The gentleman was pointing out that in these virtual name host VPS environments, right, just if one part of that server got compromised through some other piece of software, every website on that server could be impacted. Sure, it could be the default, which is why, yeah, no, actually in this case, I looked to see if they were cPanel hosted by the port number. So I think it's 2802 or 2804. If they were actively listening on 2804 with a web page, I assume that was a cPanel controlled site. But there's a flip side to your question as well, which is that was why I had so many URLs removed from my duplication. So when I went from 176 to 120, it was because if a single site on a virtual host got compromised, whether it was cPanel or WordPress or whatever it was that led to it, the whole darn server was largely all hosting it the same way. So I would have 30 different blog URLs all in one IP that all were showing the same infection, because once that box got popped, every site on it was popped. And that's the dangerous, of course, the danger as a consumer when you're purchasing a service like a cloud-based service. If you own your own Linode, that's very different than having a VPS environment, right? And unfortunately, in the VPS environment, you're only as good as the biggest idiot next to you. And you really can't underestimate human stupidity. So it's a dangerous thing. I mean, if you go cheap, you get what you pay for. And hopefully that sounded nice to the Linode people if they're here, because I'm a customer. I love Linode.
I think cPanel is a result of the shell shock echoes, because of compromise.
Right, shell shock was being used to exploit cPanel, and this is very current data, right? I wasn't able to. One of the problems with I wanted to do something more historic to say were things changing because of shell shock, Heartbleed, whatever. Like, would be interesting to see. The problem is, of course, when you start going and you go, well, what if I take the first week of November or the first week of August? 90% of the sites are down. I can't go look at them to know what they were, especially the criminal controlled ones. The repos change frequently and go down very fast, whereas the infected sites, because they're innocent people's thing, they reduce more slowly, because basically they're all forgotten blogs, and when somebody tells them it's infected, they just stop paying for it and it turns off. But because they, quit blogging years ago. But right, things like shell shock probably had an impact on cPanel. And that's something I want to ask you folks about at the end, that I'm curious about too, because the exploitation of, quote, Internet of Things devices is starting to get a bit out of hand, and almost all of them run Linux, right? And so we kind of have another point there to talk about, I think. Right, so this is sort of the detections. These are virus detection names that we use at Sophos for website stuff, but I think it explains a bit of what we've been talking about, this infected and repositories and the Google Blogspot stuff compared to the Apache sites. So Apache kind of dominated the infected sites, whereas the standout in the repositories was Google. So this is the detection names, a little word cloud I put together, but here's the top ones that are in that chart of sites we detected as infected. So SEO largely means that there was some sort of malicious search engine optimization code embedded in those pages. The JS reader just means they injected JavaScript into the page to redirect you to somewhere else where something malicious was. iframe is just literally sticking a malicious iframe in that was third-party sourced to something that had some sort of exploit kit or malicious code in it. Bad source would be a script tag, a malicious script tag that was inserted with some JavaScript, and other is all the other ones there. But I mean, when you add these up, it's the vast majority of all of the infected sites. So mostly all was malicious JavaScript, malicious iframes, stuff redirecting you elsewhere. You see very few, if you can find any in this list, actual virus names, like of any actual code that was being delivered to a Windows box to infect it. It's, well, malhappy.js is a specific type of malicious JavaScript, but there's very little there. Whereas if we take and we look at the repository names, suddenly huge variations, right? Because this is where the actual malicious stuff that's meant to harm the endpoint is being hosted, and they're more actual virus names, Troj Banker, Troj Delph, et cetera, right? And you can kind of see the top ones there, embarrassingly for us. HTML gen is, we can't be bothered to classify it, we just know it's bad. So HTML generic is basically what that means, which is half of the URLs. And interesting, I was surprised to see as many Facebook jacking and Facebook scam URLs. These are the, click here to watch the movie of the girl who killed herself because something scams that fly around in these big clouds of activity on Facebook. And ultimately, they lead you to some sort of Trojan that says it's an Adobe Flash plugin to play the video or that kind of thing. So they ranked a lot higher than I expected. And then the rest of these are just, I put these two in here because I thought they were interesting. So EXP identities for us are ones that specifically identify something trying to exploit a specific CVE number. So if something is exploiting CVE, 2014-0108, we'll call it EXP / blah, blah, blah. That was only 0.2% of them. So the exploit code in most cases wasn't able to be identified, just the malware that was being delivered. And surprised me that Google or Android was up to 0.2% of the malicious URLs for the first week of February, which is really starting to increase, right? We see about 3,000 malicious Android samples a day in the lab, and I didn't realize that the percentage of web URLs that were hosting them was getting up that high. 0.2% is actually pretty significant, considering there's not been a lot of stuff targeting mobile platforms. So I'm going to be watching that over the next couple months just to see if it creeps up, or if it's plateaued. That's just kind of where it's at these days, because if it's creeping up, that could be a very concerning thing, because Androids, when they get infected today, to my knowledge, it's 100% been Trojans. There's been no exploits used to actually deliver the malware to a phone. You load it because you're too cheap to pay 99 cents for Angry Birds, and as a result, you get a Trojan Angry Birds that has something nasty in it. And my advice to you, if you have a $600 smartphone, is you probably can afford the 99 cents. What's somebody's problem? Is it F-Droid? What's the open source repository for Android? It is F-Droid, right? Yeah. I don't use it a lot, but some of our researchers, out of curiosity, we would never recommend to our customers that they root their phones or turn off the thing to not use the Play Store. But the reality is, a lot of us, of course, we all root our phones and do all that stuff. And we've not seen anything really malicious ever show up in open source Android repositories like F-Droid, so those are largely safe. It's mostly Chinese and Russian. I'm off topic now. We could do a different. Next year I'll come back and talk about Android. So then I thought, is there regionality to this? All of us like to think that it's obviously Russia and Ukraine, and in the lab we flip a coin. And if it's heads, it's Russia, and if it's tails, it's China. And if it stands on its end, it might be somewhere else. And obviously that's an oversimplification, because Estonia and Moldova are involved as well, and Ukraine, and everybody is, right? But we have these ideas, and in one of our products we have a thing where you can country block. A lot of our customers use it, or on a UTM, where you can say, oh, I only want to have traffic to these Western countries because we're all clean and we never make any mistakes. And so I wanted to see if there was any truth to it, or if there were any patterns. So the red pinpoints represent the infected websites, and I should not have chose green, but I did, and it's too late to change it. Maybe I'll upload a new set of slides with them changed so you can actually see them. But the green pinpoints are the repositories, the places where the actual malware was being hosted. And because I really tried to do this in OpenStreetMap, but it chokes on 50 megabyte KML files. I could not find an interface to OpenStreetMap that would let me render the thing. So I went to the Google, and I broke it into 3 maps because I couldn't show. You can't do an actual Mercator map of Earth in Google Earth. It makes you make it an Earth. So I had to take several screenshots. So it's rather difficult to see, but in essence, in delving into the data closely, once I geomapped it all, what really kind of ignore these ones in the middle of the U.S., because anything that GeoIP data isn't sure thinks it's Kansas. I don't think there's actually that many computers in Kansas, but apologies if you're from Kansas. But there's a giant cluster around LA and San Diego, a giant cluster around the Valley, a giant cluster around Seattle and Vancouver, a giant cluster around Chicago, Ann Arbor, Michigan, May East, in Washington. And all of this makes sense, right? Because that's where all of our sites are hosted. That's where all the big providers are. There's a giant cluster around Dallas. Well, that's probably because people like Linode and a bunch of other people have big data centers there. So it seems to more match up with where we host our stuff than who's good or bad necessarily. I was surprised to see, I expected a lot more red and less green in a lot of the US stuff, because most US ISPs are very intolerant of intentionally hosting bad stuff. And there's a lot more bad stuff being hosted in the US than I would have expected. And what I guess the other bit is the way Google renders these is when you zoom in, each one of those pins represents like 100 pins, right? Because it can't render them, especially on a laptop that doesn't have a GPU. This thing was just cooking this morning trying to render these. This was Europe, and that had a little more pattern to it, although still pretty darn mixed and similar patterns. The UK, you can't really tell, is entirely covered in green pins. It's almost all malicious stuff. I don't know why. I mean, they don't even have good bandwidth in the UK. I'm not really sure what that's about. But it's just completely blanketed in it. I looked into these. There's a whole bunch of green ones in France, particularly on the coast just west of Paris. And that's ovh.net, and we found them to hosting a crap ton of malware, like lots and lots of dodgy stuff on OVH, a very large French provider. And Germany's a pretty interesting mix, and then as you head east from Poland, it starts getting greener and greener and greener, less and less infected sites and more malware repositories. So that does kind of reflect some of the patterns we see with bulletproof hosts operating in Bulgaria and Moldova and these countries where there hasn't been any political or police pressure to shape up, and they're making a lot of money and profit from this activity. So there's no reason not to do so. And then Asia, surprisingly few pins, but China, I guess, again, not surprising, almost entirely green dots and almost no red dots. And that's reflective, again, of what we see in malware. When we see malware originating out of China, or most of Southeast Asia, to be honest, it's almost always designed to steal information. It's almost always a Trojan. It's almost always coming in a malicious document of some sort. We don't see them mass infecting websites. We don't see them writing malware for profit that's designed to steal banking credentials. They'll steal credentials, but if they're stealing credentials, they want to steal the RSA tokens, right? It's political motivated or espionage motivated primarily for the malware we see coming out of Asia, and I think that's reflected in that almost all the things we're seeing in Asia, in particular in China, are all green because they're just actual places they're hosting the malware for you to download once you're compromised, as opposed to them mass infecting websites like Russian gangs do simply for profit, like the crypto locker guys or something. And unfortunately, I didn't get to roll Australia around the corner there, but Australia was very reflective of Canada and the U.S. It was a pretty big mix, and all of it was in Sydney and Melbourne because there's really nobody anywhere else in Australia. I love going there. I get to go a couple times a year for work, which is fantastic. But the middle, there definitely is no connectivity. So looking at what we can do to minimize our contribution, I kind of blanketed all my friends around the world at Sophos Labs. In particular, I should say thank you to my colleague Tim Easton in our Australia lab in Sydney, who's one of our Linux experts. Him and I had a good powwow when I was down there in December to talk about this talk, and kind of brainstormed some ideas, like what ways are guys getting into our Linux boxes, aside from what I've been kind of harping on in the talk. I've been talking about WordPress and Drupal and cPanel and PHPMyAdmin, which certainly vulnerabilities in those apps do lead to a lot of these sites being compromised. But what other things, we end up having to help our customers through a lot of painful situations with their boxes being compromised, and what mistakes do we keep seeing happening, or what are the crooks using to get in? And a few things come to mind, that are reducing the impact. And going in particular to WordPress, I put the cloud up there. Cloud hosting this stuff, instead of people doing it on their own, is the best thing that can happen, right? Most people out there don't have you guys as their friend or the person they're hiring to help them with their site necessarily, that know what they're doing, that can actually set the thing up correctly, right? They're just paying the $2.99 and clicking the button that says, yes, I want WordPress. And they don't know what it means, and they don't know how to handle it. So moving the stuff to the cloud, I think, has been brilliant. We're seeing fewer and fewer. So I quickly grepped through the WordPress ones in the red and blue charts just to see. 90% plus of them were WordPress 3 dot something, which tells me they're not hosted at WordPress.com, and they're probably not been installed in the last year and a half, and they're not being maintained, right? Because 4.x, I think, has been out for like 18 months or something. So if they're running 3 or older, they're just abandoned blogs, right? Host it on WordPress.com. You can abandon it as long as you want. It'll always be up to date. And I think more and more people are doing that. And I really encourage when we have amateurs and friends and family and neighbors coming to us saying, hey, I want to have this thing. I just want to pop it up on the web. Do it in the cloud. Like, let the cloud provider take care of it. Let Salesforce do it. Let WordPress do it. Whatever it is, right? Like, if you're a proper admin and you want to design and maintain your own systems, don't move it to the cloud if you don't want to. I don't want to lose the control sometimes. Of certain applications, I want full visibility in everything that's happening. I want to see the network traffic. I want to know who's trying to log in. I want to know everything. And I don't want to surrender that to the cloud. But if you don't have that talent and you don't have somebody like that to help you with it, I think the cloud can help solve a lot of this problem. These boxes are almost all up for a single purpose, and they got put up at one point in time, and they were never touched again. And now they're causing harm to the neighborhood, if you will, by harming everybody that visits them, and that's bad. I work for an antivirus company, but do something with security stuff for your web assets. If you don't want to use Office antivirus, use Clam. If you don't want to use Clam, borrow your friend's antivirus he paid for and scan it once a month. Do something, right? Because most of the stuff's really easy to detect. Because you're doing nothing, they're not using polymorphic code. They're not doing anything hard because they don't have to. You're not even looking. They can just put it there. And IDSs and IPSs and WAFs and this stuff, I mean, they're not foolproof, right? They're not going to stop, to the proverbial NSA. I mean, if you're worried about the NSA, you're going to have to go find bin Laden's cave. I don't know what to tell you because you're going to have problems, right? But if you're worried about stopping the ninnies that are spreading the 178,000 bad URLs a month or a week, really, a little bit of WAF and a little bit of IDS and a little bit of antivirus goes a long way to stopping that stuff. They're not doing anything sophisticated. They're counting on the fact that you're sleeping at the wheel when it comes to security. Two-factor. If your provider, if you're hosting something important and your provider doesn't have two-factor, get a new provider. Like, passwords just suck. We're bad at them, and if you're the best in the world at them and you use a different one everywhere, it can still be stolen. It can be stolen because your provider's crap and they didn't store it correctly. It can be stolen because they compromised your machine. It can be stolen because they guessed your LastPass account password. Second factors really make a huge difference, and we don't see compromises happen almost ever when second factor is involved. I thought that was interesting that the person was saying, shh, don't give your password away, and I was trying to find an image for SSH, and I figured, well, it kind of fit dual duty. I mean, obviously don't share your password and use SSH, turn off Telnet. Does anybody here still use Solaris? Okay, that's good. We're all reformed. Because I think Solaris, last time I loaded Solaris, it still had Telnet on by default. But I mean, but the key here was, the reason I put it there was to remind myself, use key authentication. The amount of brute forcing of SSH passwords we see is insane. Like, there's tens of thousands of attempts at every major site out there these days. It's constant. There's tons of bots doing it. Turning off interactive authentication and switching over to key authentication goes a long way to just putting an immediate halt to that activity, because the bots can't even, they just drop. Like, that's the way to go. Please patch. And this is the other thing, tools. Like, if you're building a system for production, don't leave your tools laying around. Right? These guys are using all the tools. They're using your TCP dump to sniff your network because you have TCP dump installed in your DMZ. Right? You're using Netcat because you left it there because it was handy when you were troubleshooting, and they're using Netcat to connect to your systems to figure out which unpatched Oracle server you forgot about. Right? They're embedded in your own environment when we're talking about more advanced attacks, and they're using your tools to do it, largely left on Unix and Linux systems, Macs. These guys can hide on a Mac inside your network for a year and you'll never know, because a Mac user will not load antivirus, and it has all the tools necessary to compromise your entire network already on the box. So we really got to look at these things carefully and watch, in particular, production Linux boxes, not installing GCC, not installing TCP dump, not installing Netcat. Get all that stuff out of there. It's a production box. You troubleshoot from the laptop or the VM or the something else. Okay, that was the lecture mode. I'm done with lecturing. And to conclude, and this is a question, I mean, Lizard Squad, somebody reminded me of earlier. We saw over Christmas, Brian Krebs wrote about it. I looked into it. I don't know. I've got the source code for the bot, actually. And it was home router firmware that was compromised that brought down Microsoft and PlayStation Network and all that was being run on Linux-based routers with default passwords from one of 148 vendors. These things are horrible, right? These boxes are terrible, these router boxes. I mean, almost all of them have ridiculous vulnerabilities in them. They're listening on the outside when they're supposed to be listening on the inside. They've got, just all kinds of stuff. And there's I mean, I don't know what advice to give you on that other than buy something nice and shiny that uses OpenWRT or something, or DDRWRT or Tomato, or pick your flavor of favorite open source router. But these things are terrible, and they're starting to be exploited by the bad guys. They're realizing that why brute force SSH attack the server when I can log it as admin123, and I'll get into 10,000 routers, and 10,000 routers sitting on cable modems is powerful enough. Oh, you laugh at a MIPS processor. Oh, it's not very fast. Well, it's fast enough to take down the Microsoft Live network when you've got 150,000 of them, right? And that's getting to be the new problem here. I think, you know, as more of us move our WordPress to the WordPress cloud and these types of things, mainstream Linux boxes maybe will be under less attack as we get better at securing them, and as the amateurs perhaps move to other solutions that are more and better managed. But the problem now is going to be, I mean, Samsung Smart TVs, it's creepy enough that they're listening to your dinner conversation. But, I mean, it's kind of weird, right? Like, I only watch TV when I'm feeling dumb, and I'm not sure I want to be outsmarted by the television. And another thing we're seeing a lot of is Samba servers being used to host malware, and we can't figure out where the malware is coming from in a company's environment. There's the Mac box in the marketing department that's running Samba shares, and the Windows malware is on there, and of course they never scan it. And then you clean up the infection on all your Windows boxes, and then a week later it comes back, and you're like, where is it coming from? And you can't figure out where it's coming from, and you scan the mail server, and you've blocked downloading EXEs, and you know, you're scratching your head trying to figure out where it is, and a good chunk of the time it's a Linux box or a Mac box sitting in the corner running Samba, innocently serving up something malicious over and over and over again in the environment. And if you're a web developer and you can't at least get 10 things right, I recommend the OWASP top 10. If you can get those top 10 things right, you're already going to be ahead of the game, because I have not seen a website compromise in a long time that hasn't involved like one of the top 4. So let's say you can get the top 5 of the OWASP top 10 right. You're going to automatically, security through obscurity, your way down the list of being attacked. We're really, really, really bad at this stuff, and we need to at least understand that there's a checklist of the basics we have to get right at a minimum, whether we're security experts or not, because we're really creating that bad neighborhood, right? Like it may be great that nobody's stealing your banking credentials from the server that they compromised, but putting tens of thousands, hundreds of thousands, millions of Windows users at risk is a rather bad behavior, no matter how you look at it. And I recommend that hopefully we all try to do what we can to stop that. Anybody have any other smart devices that they've played with? Has anybody ever found a secure one? Because I mean, I've seen these the Philips light bulbs. They're hackable. The Nest thermostats, the LG dryer that will text you when your laundry is done. Who does laundry when they're not home? Like, I wouldn't run the dryer when I'm not home. I don't need to be texted. I mean, I love gadgets, but this is getting, you know, there's a million of these things out there, and they're all quite hackable. And what I've been playing around with the idea on that stuff for the Internet of Things, because I want all the Internet of Things. I just don't want other people watching my baby monitor. And so I'm thinking, you know, like an HTML5 VPN kind of situation is a good way, where maybe you have to log into a web page on the outside of your router that then lets you into a page that connects to the inside web pages, sort of a, you know, poor man's intranet kind of thing. Yes, sir.
Raspberry, and all the other flavors. What do you think of that?
Oh, so the question is about the Raspberry Pi operating systems and related BeagleBoard and da-da-da-da. Well, I mean, they're Linux. I mean, primarily, right? I mean, I haven't seen anything particularly bad in any of them. I mean, personally, I've got a B+ running Raspbian, and I've got a original Raspberry Pi running Arch that I use for war biking. So as an attack platform, it's fantastic. It's small. One of those old 10,000 milliamp batteries, you can go all day. But I mean, if you keep it up to date, I mean, Debian, Arch, these things are great, right? I mean, there's really no difference that I've seen as far as security for the ARM builds that go on these portable platforms. Yes, sir?
Yeah, since you're from Michigan, the cars are increasingly into those black boxes. CAN network is super easy to hack.
Yeah, I saw Charlie Miller's tweets today about hacking his Jeep firmware.
So there's going to be a whole new slew of problems in that realm.
Yeah, and I haven't, most of those aren't Linux-based to my knowledge yet, although so Tesla's is Linux, because theirs was hacked in China. So the question, I guess, for the audio people that can't hear this gentleman was about, of course, all these cars being hacked and the CAM networks in the cars not being secure at all, really. I mean, there's not even a pretend firewall. So yeah, and they are. I mean, I've got a Ford, and when it blue screens, it shows the Ford logo.
That's running Windows RT.
Yeah.
Switched recently. That's good, at least.
Yeah, I mean, it's. I guess the good thing is so far nobody's really doing it wirelessly, but that's only because it's hard to go buy 40 cars to play with to figure out how hackable they are. I mean, the only thing stopping them all from being ripped to shreds is that most of us aren't willing to not have our car next week because we hacked it and we can't get it back together again. And it's a really expensive thing. And I predict as the automated models become older where they're cheap, we're going to see this stuff explode, right? Because I will go buy 10 cars. And it's not going to be pretty. I'm just trying to move around. You, sir?
At the beginning, you had mentioned Amazon not showing up much
Mm-hmm.
this year as opposed to last year. I wasn't exactly clear on what that was. If you had put that within the same thing, Apache and whatnot. A lot of people do run Apache on Amazon instances. Were you referencing like S3 or what?
Yeah, I went and looked. Well, I went and looked through. One was S3. So the question was why about my commentary on Amazon. It was a little fuzzy, right? So if you're running EC2, you're probably running Apache on your EC2 instance. It wouldn't show up as an Amazon host. So yeah, I was mostly referencing things like S3. But I also went through and looked at their net blocks just out of curiosity in the IP data, and Amazon's net blocks were largely not there, implying EC2 is pretty clean too.
So is there overlap in the stats? In other words, if you counted something in Apache,
I didn't count anything I did by hand on the IP data in any of the stats I showed. I just did it anecdotally on my own because I was curious, because for the same reason. When I went, ooh, that's weird, I'm only seeing this small amount of Amazon, and I'm like, right, but that wouldn't count EC2. I wonder if EC2 is still a mess, because we had seen a lot of nasty stuff on EC2 a few years ago. And I just went personally and went, these net blocks that are known EC2 blocks, are they in my data? And there was almost none. And so I went, oh, okay, that kind of implies that they have cleaned it up a bit. You, sir.
Yeah, just two comments. One, Amazon's gotten pretty nasty about keeping their house clean. They're very rapid at responding.
Yes.
I read a magazine about it, and not out of firsthand. The other one is televisions now are all running Linux, and of course they're all connected. That's the big thing. And the problem is that there's no incentive for those companies to constantly keep those devices up to date. So after TVs, it's been in manufacturing less than a year. The manufacturer dropped software support for it. So you have tons of devices out there with long-lasting vulnerabilities sitting in them, and they'll sit there for 10, 15, or more years based on how often people turn over equipment. And that's going to become a real problem in the future.
Yeah, that's why I put it in the slide. So the commentary was just about particularly things like smart TVs, and that they don't get patches, if at all. And unfortunately, we're the same with our Android phones these days because of the way that Google's ecosystem is set up, right? My dad bought a Droid phone of some sort from Verizon 3-4 years ago, and when he got it, it had several major browser vulnerabilities I was concerned about, and it already wasn't supported, and it wasn't old, like you could still buy it at the store. You couldn't get an update for it. And I wasn't really thinking that my dad was in the mood to load CyanogenMod. So, I mean, these are real. So, watch if you read my blog, nakedsecurity.sophos.com, where I blog at Sophos. Keep an eye on that. I've been building up this long rant that I'm not sure what's going to happen with it yet. But what I call the security warranty. I think every package should say this product will be supported for this amount of time against security vulnerabilities. And as a consumer, you should be able to know when you're buying something. If this is 300 and this is 350, why? Is it better? Is it just the brand? Is it because it's more fashionable? Or does this company stand behind their product while the other one's going to abandon you? And until you bought it and broke the seal, you have no idea. We have no ability to know when that TV, if ever, it's going to be patched, do we? And it would influence my purchasing decisions for sure, because I love these gadgets and I want to be able to play with them, and I want to know that I've got a partner in fixing them if they're broken. You, sir.
Cars. Rather than buying a car, you go out and you rent a car. And, gee, it won't start.
Are you a lawyer? I'm just curious if this is legal.
Oh, I'm sure it's not. But that's never stopped criminals before.
So this gentleman was recommending, we won't use his name, but perhaps that I rent cars exceedingly frequently that fail mysteriously in my spot in the parking garage.
Well, that won't stop criminals from doing it.
It certainly won't stop criminals from doing it, that's true.
And
But there's a lot of things that I would like to do as a security researcher that I don't, even though criminals are allowed to do it.
but that's why we'll see criminals hacking the cars long before.
Oh, we'll see. You think criminals will hack the cars before? I don't think they will.
Because they can get at, they have.
What's the benefit in hacking the car as a criminal? I want money if I'm a crook, typically. So what's the advantage to me hacking the car if I can already just send it RF signals and unlock the doors? I mean, we already do that. I mean, you can get any BMW in town you want. So is there a reason to hack the computer, right? Like, the only advantage I see is to steal stuff. So I either want the contents of the car or I want the car, which I can already do with a Slim Jim or a radio.
So once we have self-driving cars, you can hack the car and it'll drive to wherever you need it to go. It'll drive right to the.
But why won't it now? I mean, arguably, it will do that now.
How about Bluetooth to a device in the car?
Bluetooth to it. I don't understand the question.
Well, I'm just thinking, I don't know, but you could hack the car,
Mm-hmm.
you could access Bluetooth to access devices in the car, which would contain information.
Sure. Okay, so data theft through the Bluetooth in the car being paired to something in the car like the iPhone or something like that. Yeah, I suppose. It just seems like it's a lot easier to break somebody's website and just get 20,000 victims that way. I mean, this is always about low-hanging fruit. And the car thing, I think, is the concern is public safety, and should manufacturers be doing a better job of protecting us as opposed to street thugs hacking cars, because that seems too much bother. It's sort of, last year I did a lot of talks on credit card theft, and people ask about chip and pin security, and there's several flaws in chip and pin that are interesting as a researcher. But I wouldn't bother when it's a lot easier to break into your web server and dump your MySQL because you didn't store credit cards securely. I'm not going to start worrying about the chips until you get rid of the stripes and I can stop stealing databases full of credit cards, and then maybe I'll look at it. And it's the same thing, I think, with the cars, to be honest. I mean, the value of hacking the car, maybe there's some data, maybe it makes it easier to steal the car and have it drive itself to somebody else's garage so you can frame them. I don't know. There's interesting ideas there that could certainly, I mean, I'm sure we could brainstorm a movie or two for Hollywood. But the question is that easier than Slim Jimming the car and stealing the car, which is actually quite trivial. So I think I would just carry a Slim Jim myself. It's a lot easier. iPhones are more expensive. Any other questions? Yes, you sir.
There might be some interest in the data in aggregate if you can get into the actual car company, their central system.
Yeah, data in aggregate from the manufacturer's systems where they're sucking in it. And I've heard it. I've heard concerns from some advocacy groups around stalking, this type of thing, where if you could talk to the car while it's parked in the parking lot and see where it goes every day, you might identify the home of a person you want to victimize. You might know when they're alone. You might be able to find patterns that perhaps put you at physical harm, which would be, that's a determined, motivated attacker going after someone, right? You, sir?
So with the IoT, a lot of us are pretending that we're not behind NAT and we're not behind IPv4 firewalls. A lot of these devices aren't exposed to the WAN. It's the user that's opening these forwarding. So we need to not put the blame on these devices and put the blame on us. We can expect a certain level of security on these devices, but we need people to not be idiots as well. So if you're opening up port forwarding to your smart TV, I hope I can get into your TV and it's your own damn fault. If not, then you have a problem. But a lot of the exploits that have happened on these routers are because people have enabled the web services on the WAN side. They've gone ahead and done this. If you look at the ones that are actually exploited, there are few and far between, like the Joel's backdoor that was hard-coded in. Those are not the common attacks. The common attack vectors is because somebody has purposely enabled that port forward or purposely enabled web management on the external side of their router, meaning somebody logged in and tinkered when they had no idea what they were doing, and you're not going to be able to stop that unless you have proper training on using that.
Right. I'll try to repeat. That was really fast talking. I'll try to repeat most of what you said, summarized. And I agree and I don't on certain things on that because unfortunately there's so many different cases that were in different ways that it's not all. But the point or the question was about there's personal responsibility. These things typically are behind NAT, they're behind the firewall on your network, and you've intentionally poked a hole open that allowed somebody to get to your smart TV, your Nest thermostat, your baby monitor, your whatever, right? And manufacturers can't stop the stupid, right? Like, they can only do so much to secure the devices. I think they need to do a heck of a lot more to secure them. And you do have a lot of personal responsibility for it. The bigger problem on the router side is it's just not true in most of the cases that we've been seeing as far as the admin interface being on the outside. You having it off, it's still on. You can't turn it off. Like, it's a bug in the firmware, and there's over 100 and some, I forgot, I have to look at the article we wrote on it recently. There was 100 and some brands that it's not possible to turn off the external admin interface, even though in the web configurator it says it's off. And so, I mean, that's back to malpractice in the product again, just not working correctly. And the other one is, UPnP is a disaster. Another great Microsoft standard. Read the Wikipedia article. But we haven't seen this in the U.S. thankfully yet with the major providers, Comcast, these guys. But in Europe and in South America, we've seen quite a lot of it. And in one telco in Canada, they ship these routers locked down where you can't turn off the external admin because they want to administrate it from their side of the network. And so, and you didn't pay for the device, and you're not allowed to bring your own device, and on and on and on. It's just draconian. And you know, living in a major metro, I go, oh, find a new ISP, because I've got 6 to choose from. But most people have 1, or maybe 2, and they're both evil. And that's a real problem, right? Because you don't necessarily control your own network, which if you are in that situation, I would put your own router behind it. Let them hack the phone company's gear, have fun, buy OpenWRT boxes behind it, and NAT it again. It's not optimal. It's less than optimal. I'm past my time. I can probably squeeze a minute or two. I don't want to make the next speaker nervous. Yes, sir.
When you mentioned
but I'll hang around too.
When you mentioned the Microsoft one, basically being a hack of a weakest link sort of hack. Along those same lines, one of the things we find is that when a lot of large companies buy small companies, usually when they make an announcement long before the well-funded large company team has had a chance to do any security work at the small company, at the defense contractor that I found.
Like Comcast buying Time Warner.
Like a Raytheon buying a small niche outfit.
Sure.
So something like that, what we would find is at the time that the announcement was made, when we would later find a security breach, we'd go back to the log, and within minutes of making that announcement, that's where the forensics started.
So that's really good advice for folks that are at a smaller organization as well. So to reiterate what the gentleman said, that a lot of this is related to company acquisition, especially in defense, where there's an announcement that so-and-so is going to buy such and such, and immediately the little guy's compromised and doesn't have the security protocols or the audits in place to defend themselves against that kind of an attacker, and now they're on the inside of the network a month later. And we see that in many cases that are not even defense or anything, right? In fact, the original Sony breach during the LulzSec time 2-3 years ago was a server full of credit cards from some small game company they had bought and integrated into the PlayStation network because they wanted the game company. And that box was pre-owned with unencrypted credit cards. None of the Sony servers had unencrypted credit cards, but after they bought this company, that was their server. And it was on the inside of their network with unencrypted card data, right? This happens a lot. So that's a really excellent point and advice for folks. If you hear your company's being bought, you ought to be on the extra special lookout for a target, especially if you're a little guy. And especially if you're being bought by someone evil. All right, thank you so much for your time. I hope you enjoyed it, and I'll hang around outside if there's any other questions.